To draw a proportional cube in 2-point perspective, we can put down our horizon line, mark our left and right vanishing point, and let's say we start somewhere here. Then from this upper point to the vanishing point and this lower point to the vanishing point, I draw 2 lines which define my right upper and lower lines or edges, and I do the same for the left side. Okay, good. Now you can see that actually this distance is shorter than this distance. So now I have to guess basically the foreshortening. Because this line is smaller, this side actually will be more foreshortened. So that means actually that it will be easier to guess the less drastic foreshortening on this side. So we'll try to do it here. Okay. And then I will go over from the vanishing point, go over, try to guess maybe what might look good for the top face, and I can go down. And that's maybe tick too big. Maybe this time I go vertical first and then go over. Let's see. Yeah, that for example feels better. And let's do this one more time. Let's actually maybe make a line here, there, and there. Move it over to there. Now here you can clearly see this line is really foreshortened more. So I'm going to guess maybe this side. It's going to be easier. Now I'm judging what on the top looks good. There. No, that doesn't look good. So but it was this point roughly. And then I go down. Okay. Now if you compare actually this cube to this cube, you can clearly see that this one looks funny. And that's simply because if we apply our cone of vision over it, it gets really close to it. So that's the reason why specifically here, this area already starts to look strange, and that's because this point gets really close to the cone of vision. This area still is somewhat okay. There's one particular problem when you start learning 2-point perspective, and that's actually accurately guessing kind of like the size of the object you can draw in relationship to where your vanishing points have to be. Now, that sounds a little bit abstract, so let's try this one out with a nice comparative drawing exercise. Okay, so here I have my center point and 3 cone of visions. That, for example, helps me then to identify my right first vanishing point, right second vanishing point, etc. Okay, perfect. Now, let's go ahead and, for example, draw a cube here. And obviously, because this cube is with its lower point over the cone of vision, it will look very pinched. And that's fine. That's on purpose. There. Okay. No, actually not. This should be more like there. Let's make another layer and let's select another color, same front edge, but this time I actually go to a different set of vanishing points. Then maybe guess the foreshortening. And there. Okay. Let's do this one more time. And with another color, again, same edge. There, and there, and there. And there. Okay. And maybe to make these cubes look a little bit easier to see, let's ink them a little bit. And then you actually will notice how the perspective distortion changes. And it actually sometimes can even look like what you see with a camera when you zoom in or you zoom out. So you have this effect of tele or fisheye lens. So if I now overlay them all, between the green and the red one at the end, there's not much different on the top part. But for example, if you compare the green and the blue one, you can clearly see actually how, for example, the blue one really feels like your eyeball is right in front of that cube. So the front edge of the cube just jumps right towards you. If you take a finger and you look and you put your arm really far away and take a look at the finger, it will look like the green one. And the more you move your finger closer to your eyeball, you will see in relationship to the size of your hands, your fingertip will look really, really large. And for example, if we compare maybe the red and the blue one, you see that the red one actually looks more natural. So that's kind of like what happens when your object is too small for how far the vanishing points are apart, in green case. Or, for example, if your object is too big in relationship to how narrow or how close the vanishing points are. There are two tools we have to make sure that when we put down the framework for our perspective, we can prevent like those distortions which will look undesirable. Of course, if you want them, then you even have to break the rule. So rule number one, let's put down a horizon line, vanishing points, my first vertical, and there's line number one, line number two. Okay, and what I'm looking for, where I pay attention to, is this corner. That is the lowest corner of my object, so I will never draw anything below. And what I'm looking for is that the angle between these two lines, so this is always equal or bigger than 90 degrees. So let me show you what actually happens if we do not do that. Okay, so let's put down a horizon line. And now I put down my vanishing point and my vanishing point by actually drawing from the horizon line somewhere. Let's put up my vertical line there. Let's do this and do this. Let's quickly sketch in a tall cube. And there you can actually see that the lower area is totally distorted. And that is simply because it's outside the cone of vision. So by making sure that actually this line is the angle between those two lines is equal or bigger 90 degree, you will always make sure you will never actually hit the cone of vision, or you will never go over the cone of vision. So for example, let's try this one out. Nope. Let's make a line to there, and then let's make a line to there. Looks kind of like 90. let's go to here and look, go to there. Do you notice something? It's always at least 90 degrees. And obviously if I go to here and there, that's smaller 90 degrees, so I can draw something this way, it just will look distorted and not really desirable. Okay, so that was basically trick number one, making sure that the two lower lines are 90 degrees. And this demo, for example, also showed you an alternative way for how to estimate actually the vanishing point. So by, instead of putting my vanishing points down and then putting my lines down, I simply put my horizon line down. Then maybe I decide how much rotation do I want for my object. So how much do I only see from the left side? And then 90 degrees. I can open it a little bit if I want to. There. See, then this way I found my other vanishing point, and then I can continue sketching in my other lines. And there. And there. Now obviously, if I make this one 90 degree, I push my object pretty far down. So if, for example, I try to do it this way and I make that angle much bigger, you see I'm actually moving my object up towards the horizon line. Now, and obviously when I'm going to make the line angle basically 180 degrees, then, well, true to the fact, I'm putting it onto my eye level, kind of like now I'm drawing a house. Okay, so that was trick number one. The second measurement option we have is this one. Let's say we want to move our object a little bit to the left side. I put down my front vertical. I put down a line for my left, and I put down a line for my right vertical edge. Okay, so the line I'm actually only interested in is this one, which basically defines the distance between, as you can see, the left and the right vertical edge. Let's maybe call this one simply D. And the idea is that this distance can fit 5 times between your left and your right vanishing point. So let's try this one out. From here, for example, let's say I go to there and maybe there. So let's see. So this distance there, 5 times. Okay. So, and then I go maybe to the other side. So 1, 2, and 3. Okay. Then I go straight up. So somewhere there I will find my other vanishing point. And there. Well, there's kind of like my cube. Let's maybe complete these lines. Okay. You see actually also here the radius on the angle, sorry, not radius, the angle is bigger than 90 degrees. This approach, by trying to make sure that the width of my object is kind of like can fit in 5 times between my left and my right vanishing point, kind of like make sure that your vanishing points aren't too close or too far apart. So it's kind of like way number 2, how you can make sure that you get a good harmonious perspective. Now the thing is, they don't exclude each other. You can even use both together in tandem. So for example, like in the previous step, how I sketched down just this one and then this line, then I found my vanishing points. Then you can put your cube in, and then once your cube is in, then you can start drawing in all your 5 lines to see if everything works out, and if it does, then you basically double checked that your perspective construction is correct and will not lead maybe 2 hours later into a final drawing where then you notice that something's wrong with the perspective, because that's not really what you want. You want to see problems at the beginning and then restart, and not have to restart after you invested a lot of drawing time.